Continuing along on the practice test, we are on number 5. It says, two functions k and l are given below. Use the functions to answer each of the following questions. If a value does not exist briefly, explain why. So this is a function composition question. And we are composing functions that are given to us in different forms. This is a function in table form. And this is a function in formula form or algebraic form. And so let's look at part A. So k of L of, I can try to write a bit neater, k of L of -3. So just so you know how to situate this, this is the same thing as k of L, or that's k composed with L of -3. Okay. Although in truth, this form is generally more useful as far as understanding what it's talking about. So what is L of -3? So L is this function, the square root of x plus 3. So this is k of square root -3 plus 3. And so k of square root -3 plus 3, that's the same thing as k of 0. And so now we go to the table and we find 0 in the x column, and we see that it is matched to 5. So if the input is 0, then the output is 5. So that's our answer, is 5. And that's the way these questions work. So now if we're going to do L of k of 4, so it's the opposite. So L of k of 4, first we have to figure out what the interior function evaluated at -4 is. So k at -4, let's put this in blue. There's k, there's the k function with the input is -4, the output happens to be 5 again. So this is L of 5. And L of 5 is the same thing as the square root of 5 plus 3, which is square root of 8, which is 2 square root of 2. Okay. And let's see, whoops. Do we have more parts? Yes, we do. We have L of k of -3. Okay, so L of k of -3. Let me write that right here just so you remember what we're doing. So k of -3, though we start with k, that's the interior function. K of -3 is -4, so this is L of -4. And that's the square root of -4. So this is the square root of -4 plus 3. And I can trace this back because this was, this was L of -4 because k of -3 is -4. And so then that's L of -4. But this is square root of -1. And that is a imaginary number, a complex number. Okay, so this is not in the domain. So D and E, at least for our purposes, okay? If we were studying complex and imaginary numbers, we could allow this, but we're not, so. Okay, and I believe, yep, that's it for number 5. So let's take a look at number 6. A grape is thrown upwards off the top of a tower that is 30 feet tall. The height of the grape at time t is given by h of t equals -16t squared plus 4t plus 30. And then we have questions. What is the maximum height of the grape? After how many seconds does the grape hit the ground? And what is a suitable domain and range? So this is a quadratic function. It's a quadratic model. This is not an optimization problem. This is a projectile motion problem. And I think it would be useful to at least roughly graph this. So at time 0, so what is our graph? So we've got time and we've got height. At time 0, let's make a t-chart. So when t is 0, h is 30. Sorry. So I got that by plugging 0 into the model. So times 0, we are at 30. So just what does that mean? That means that when we start, well, we knew this already, but it means that we're in the top of an object that's 30 feet tall, right? So there you go. What else do we know about this model? Well, I know it's going to be a downwards facing quadratic because it's negative leading coefficient. So it's going to be something like that. Excuse my poor drawing. But this helps us to visualize the answers to the remaining parts. So part A says, what is the maximum height of the grape? So that maximum height is going to occur like there, like at the vertex. And specifically, that's going to be the y coordinate. So we need to get the vertex, and that's negative b over 2a, f of negative b over 2a. Well, my pen stopped working. Here we go. So negative b over 2a is negative 4 over 2 times negative 16, which we can simplify this. That's the negatives cancel, and then 4 goes into 16 4 times, so that's 1/8. And so then we need to take that 1/8 and put it into the function. So f of 1/8, because that's the height. This is the time. We want the height. So f of 1/8 is the height, and that's going to be negative 16 1/8 squared plus 4 times 1/8 plus 30. And let's see what all this is. So that's 4 and 8, that's a half. And then 1/8 squared is 1/64th. And I think we can do some simplification there. $16 goes into 64 4 times, but this is still a negative, so that's 1 over 4. So altogether, you can check my math here, but this is 30 plus a half minus a fourth is 30 and a fourth. So that's 30 and 1/4 feet, which we could get that's an improper fraction. We could get 30.25 feet, right? Okay, after how many seconds does the grape hit the ground? So the grape is going to hit the ground. That's going to correspond to a 0. Not the number 0, but a 0. And a 0 is when the model equals 0. So that's when does this happen? So we have a quadratic. We could use the quadratic formula. Maybe actually we can divide. We can divide everything here by 2 because you got a 0 on this side. So we divide the 0 here on the right and the left, and that would be minus 8t squared plus 2t plus 15, which is just a bit easier to think about. You don't have to do that, but it's kind of a simplification. And right, will this factor? This might factor, but maybe it's not going to factor. But maybe it is going to factor. But maybe it's not. I don't know. Let's do the quadratic formula. So t equals negative 2 plus or minus the square root of 2 squared minus 4 times negative 8 times 15 over 2 times negative 8. And now we're going to do some simplification. So this is going to be a little bit messy. So those twos, you know what, let's be careful about that. I don't want to do that. I'm going to leave this 2 here. This is going to be 4 minus, what's all that? So we've got, I'll just do the calculator. That's 480, but it's a positive. And that's negative 16. And so that's 484 under the radicand, which lo and behold, that is a perfect square. So that we got lucky. So this is minus 2 plus or minus 22 over 16. Now I don't want to leave this yet because there's actually a little bit more we need to talk about here. This is 2 answers, right? So we'll get to part C in just a moment. But so we've got minus 2 plus 22 over 16. Oh, negative 16. And minus 2 minus 22 over negative 16. But only one of these is possible because now the scenario is that we actually have this grape falling, and we want the positive time. So there is some other time over here that's actually not part of our scenario. So we just want to make sure that we're taking the positive of these 2 answers. So which one is positive? So it's a little bit confusing. Actually, this is the positive one, because this one, when you do this addition and then divide by negative, the whole thing is going to be negative, but this one will be positive. So this is minus 24 over minus 16, which is positive 24 over 16. And then that, what is that? So 8 goes into the 16 twice, and 24 3 times. So that's 3 times. Okay, so that's my answer. All right, now finally we can get to part C. What's the suitable domain and range? Okay, so the domain, suitable in this, suitable means because no negative times, and also no negative heights. Okay, so our domain is going to start at 0. This is the domain. The domain is going to start at 0. And where should we end the domain? Well, we don't really care about the domain past the time of impact. And we actually found the time of impact in the last problem, which was 3/2. So 0 to 3/2. Now our range, that's vertical, that's the height. And we don't care about any height underneath 0. I mean, now looking at this picture, basically I'm going to go from here up to the vertex. And so what was that maximum height? It was 30.25 feet. So our range will be 0 up to 30.25. And those are brackets. Brackets because all those points are actually included in the situation. All right. This will be the end of this video, and then we will pick up the next video with number 7.